When we're thinking about the data that we're using in a statistical study, it's important for us to remember that these data are not coming from nowhere. We actually went out and observed them somehow, or perhaps we didn't observe them, but somebody had to actually go out and observe them. And the manner in which they actually observe the data are going to change how we have to use those data in order to draw conclusions or make inferences about the population that we care about. Not all forms of data collection are going to be created equal, and depending on the form of data collection that were used, there might be different considerations for us to make regarding the actual use of these data. And so the method in which data are collected is going to be critically important. And it's critically important for us to understand in order for us to be drawing conclusions that are relevant to the questions that we actually want to ask. It's going to be critically important for us to understand to actually really have a sense of what are the limitations on these conclusions? What can we actually say about the world around us? Really, we're going to be thinking about mainly two kinds of statistical studies. There are mostly two different ways that we can go and collect data. And then within each of these, there would be tons and tons of different options for data collection within them. But there's two overarching ways that we might collect data in a statistical study. And so when we say statistical study, what we're really meaning is any study in which data are collected, right? Whether this is a formal scientific study or we're just thinking about collecting data for use in day-to-day life, right? We call it a statistical study when it is sort of centered around collection and analysis of data. And the manner in which those data are collected is going to dictate the type of study, right? So all statistical studies can be roughly speaking grouped into one of two different kinds of statistical studies. Based on the kind of statistical study, it's going to require different forms of analysis, but it's also going to lead us to different types of conclusions. And we'll see exactly what we mean by that shortly, right? But knowing how the data were collected is going to be important, right? If you have the same data set and it came from two different sources, you're going to have to treat those differently depending on which source is which. Okay. So the first type of statistical study is what we call an observational study. And the key defining feature of an observational study is that the researchers themselves, the data collectors, are not actually directly intervening or influencing the outcome that's being observed. And so it's called observational because in some sense, the researchers are taking a step back and they're just observing what's going on. Now, sometimes that observation actually takes a lot of effort from them, right? But they're not directly intervening. The fact that the researcher is there is not intended to change what's actually being observed. Okay? So one really common form of observational study would be a survey study. Okay? And so a survey study is a specific type of observational study in which the researchers are going to be collecting information from a particular group based on some set of questions, right? So maybe you've answered surveys before, right? There's someone who is sort of requesting you to answer a set of questions and you give your opinions or your thoughts or your answers on that set of questions. And if you think about what's happening with a survey, right? The researcher goes out, they collect a group of individuals, they give those questions to the group of individuals, and the individuals are providing the answers there. At no point is the researcher trying to intervene and trying to sort of influence what is actually being said. They're just collecting data as they already exist, right? And so because of that, it's observational. You could also think about observational studies as being sort of more literally observational, right? So you stand out in public somewhere and you count the number of people that enter a specific store. Or if you're a biological researcher, you go out into a wildlife habitat and you count the number of some species that exist out there. Or you watch the migratory patterns of that species, right? And so there's sort of ways that you could observe the world as it exists. Not all observational studies are survey studies, but survey studies are one very common form of observational studies. The other sort of major class of statistical study is what we would call an experimental study, and where observational studies are characterized by the researcher not intervening, an experiment is characterized by the researcher intervening. So they specifically are going to be manipulating what is happening in the study to see how that influences some outcome, right? So the most common kinds of experimental studies, or perhaps the easiest ones for us to keep in mind, are drug trials. And so in a medical drug trial, what we're thinking about is there's a group of participants that have come in in to the study, and we're thinking about trying to treat them for some disease or illness, right? And the researchers themselves are the ones giving out the treatment. So some group of them are going to get one treatment, a different group of them are going to get a second treatment, and the researchers are going to collect information on what happens to both of those groups. But those groups didn't just exist out sort of in the wild by themselves, right? The reason they have the treatments that they did is because the researcher themselves was intervening in that, right? As soon as the researcher steps in and says, you get this treatment, you get this intervention, this variable that you have is set to this specific value, then we're doing an experiment. And so it's either experimental if there's intervention, or it's observational if there's no intervention. So work through some examples here to sort of make sure that this is all clear. If we're thinking about, say, a pharmacological trial, right? So a drug trial. So researchers are trying to investigate the effectiveness of a newly developed medicine at treating some particular disease. We're trying to identify, is this observational or is this experimental? And generally speaking, these are going to be experimental studies, right? The researcher is actually going to choose who gets which drug in this trial. Because they're choosing who gets the specific drugs, they're influencing the outcomes that we're observing here. So these are typically going to be performed as experimental studies. And think about political polling, right? So pollsters are going to try to infer voting intentions for individuals that live in some region or in some country, right? And they do this typically by reaching out to a group of individuals and asking them for their voting intentions, right? And so in this case, a political poll is a survey, right? You're reaching out to individuals, you're asking them a set of questions, and all surveys are going to be thought of as being observational studies. And so political polling is going to be observational by nature because the pollster is not influencing the outcomes that they're observing there. They're not changing something about the individual and seeing what is your preference. They're just simply asking, what is your preference? The preference exists whether the political pollster is there or not. And so they're just observing the truth that actually exists. We can think about doing, say, market research. And so marketers at a company, say, are going to recruit a group of individuals and bring them in to determine their affinity towards their offerings. And so we have to be careful in this situation, right? Because on one hand, the marketers are going out and they're collecting these people and they're bringing them into a room and, say, doing a market research trial group with them. But within that focus group, we're not necessarily intervening on anything, right? This is sort of just a convoluted type of survey that they're running here, where they've gone out, they've collected people, they've probably paid them money to come in person to sort of see the product offerings, but they're not actually intervening in any real sense on this. And so they're just observing them in a different context. And so this is still going to be observational. It's still sort of a survey, right? Because they're not directly manipulating the outcome. And so this is where it's important to be able to sort of distinguish, is the researcher intervening on one of the variables that we care about to try to influence the outcome, or are they intervening just because that's how they have to actually collect the data, right? You can think about doing some agricultural research, right? So scientists are attempting to infer how different types of fertilizers are going to impact the yield of a variety of crops, right? And so thinking about how you would actually design this study. In this study, the scientists are probably specifically applying fertilizers to different crops or to different fields, and then seeing how does that impact the yield, right? And so there, they have specifically intervened on those crops. They've specifically said, this group of crops, you get fertilizer A, this group, you get fertilizer B, and then we see how that changes the outcome. Because they've specifically intervened, this is going to be an experimental study. A/B testing. A/B testing is really common right now, and so typically we're thinking about this as on websites or on mobile apps, right? But so a website is going to show different versions of the homepage to different groups of users to determine which one is going to convert better, which one gets users more engaged, which one gets them to purchase the item, whatever else your outcome might be here. And so in this case, right, the experimenter is actually going to be the person controlling the website, programming the A/B test on the website. And here, they're directly manipulating the experience that the user has, right? They're not just observing what happens to the user on the page. They say, if you get page A, then how much do you purchase? How do you behave on the website? If you get page B, how much do you purchase? How do you behave on the website? And so there's a specific intervention here. And so an A/B test is an example of an experimental study. Okay. think about conservation research. So researchers are studying the migratory patterns of an endangered bird species, right? Now, typically, if we're thinking about what's going on here, they're probably literally observing this bird species, right? They're probably going out to where they know the birds are going to be and watching their migratory patterns, following them throughout time. They might even be tracking them in some way, right? Maybe you have chipped the birds and then you're tracking where they're going. But all you're really doing there is observing the patterns that they actually have. You're not trying to influence how they migrate. And so because of that, this is observational, right? There's no intervention directly here. Now, identifying observational versus experimental studies is important because the types of conclusions that we're going to draw, or how easy it is to draw different types of conclusions, is going to differ whether we have an observational or an experimental study. Okay. So observational studies tend to be easier to conduct, and they tend to be less resource intensive, right? So the reason we like observational studies is because they are cheap to do. This is almost always going to be the case. If you need to collect a bunch of data, it's probably easier to do this observationally than experimentally. There's also going to be times that observational studies are the only possible reaction here, or the only possible type of investigation. And so we can think about trying to investigate, does smoking cause lung cancer, right? So if we want to ask this question, and I'd implore you to think about how you would actually study this experimentally, right? In order to do so, you would need to give some individuals cigarettes to smoke. You would have to force other individuals to not smoke. And then you'd have to see, do the ones that you have forced to smoke develop lung cancer at higher rates than the ones that did not smoke? And of course, this is never going to be a study that you can actually run practically, because you can't force a group of individuals to smoke because you think that it's going to give them lung cancer, right? That's highly unethical. And so instead, we have to rely on people's actual smoking behavior, right? And so that makes studying smoking a key place for an observational study. There's really not going to be the possibility of doing an experimental study there. Now, the problem with observational studies is that they're often going to be impacted by what we would call confounding biases. Okay? And so the specific problem with confounding biases is that it's going to make drawing causal conclusions more challenging for us. So if we think about that example of, does smoking cause cancer? Okay. And so what we do is we say, we're going to go collect information, and some group of the population is already smoking, and some group of the population is already not smoking. And then we could observe them and say, do the smokers develop lung cancer more often than the non-smokers, right? And that's a sort of a valid way of asking this question. If we wanted to say, does smoking cause cancer? We have a harder question to actually answer here, right? Because in our population, it might be the case that the people who smoke end up with lung cancer more often, but we don't necessarily know that it was the smoking that caused this, right? And so why is that going to be the case? Well, you could imagine that the people who smoke also engage in other risky behaviors, right? So maybe if you smoke, you're more likely to drink as well. And if that's the case, maybe drinking causes lung cancer, but the people who smoke drink more on average. And so then drinking is causing the lung cancer, but people who smoke drink more. And so the smoking group is going to have more lung cancer because of drinking, but not because of smoking. Right? And so in the case of observational data, we have to be very careful for these types of confounding biases. And we need to use sort of more advanced techniques if we want to remove the impact of these confounding biases. It's not impossible to do. You'll often hear that if you have observational data, you can't draw causal conclusions. That's not true. But it is true that you have to be a lot more careful with your analysis of observational data. And you have to be a lot more careful about how you're drawing conclusions from the analysis of observational data. On the other hand, experimental studies, and specifically a well-designed experimental study, are going to typically provide more reliable evidence. We're not going to be worried about sort of the confounding biases because we get to intervene on the individuals themselves, right? In the case of that smoking example, if we could actually give half the population cigarettes to smoke and make the other half not, then we don't have to worry about are smokers and non-smokers different, because we got to choose who were the smokers and who were the non-smokers, and we can make those groups as similar as we want them to be. Right? So in a well-designed experimental studies, confounding biases are going to be less prominent. But the big concern is going to be the cost of running this, right? So the causal conclusions are going to come sort of more easily, but it's going to come at a far greater expense for running the actual study, right? So it's a lot harder to run an experimental study. It's typically going to be a lot more expensive. But the benefit you get out of that is that if you design an experiment very well, then you're going to have sort of easier, more reliable conclusions. And so the key lesson here is that when you're thinking about the types of studies that you want to run, right, you need to select the type of study that you're going to be doing based on the question that you're actually trying to ask, right? So is this a question that's going to be answered better through experiments? Is this going to be a question that's answered better through observational data? Do you have to use observational data because an experiment would be totally unethical? Do you have to use observational data because you can't afford to run an experiment? Right? These are the types of considerations we're making. And once you've made that choice, once you know how the data are going to be collected, then you have to analyze the data accordingly, right? You have to keep in consideration, this was observational data, so I have to watch out for confounding. Or this was an experiment, and so confounding's probably not going to be a major issue for me here, right? And so when we're thinking about the types of studies, we're sort of differentiating where the data are actually coming from, but this is going to have important implications for the types of conclusions that we can actually draw.